Hello and welcome to Empowered Learning. This particular lesson will be on how to derive a graph of the inverse cosine function given the cosine function as its basis. So when we start talking about inverse functions, what we have to keep in mind is that a function that has an inverse is a function that's considered to be what we call one-to-one, which means for every x value or x coordinate that the graph of the function has, it has a unique y value to go with it. How we graphically test for that is using the vertical line test and the horizontal line test. The vertical line test says that if we draw vertical lines anywhere in the graph of the function that we're considering, and the vertical line only intersects the graph once, then it is a function. If it intersects it more than once, then it is not. As you can see here for cosine, we draw vertical lines in a few places and we see that cosine x is indeed a function. Now the horizontal line test, it says the same thing as vertical line test, but it's testing to see if we were to quote unquote flip the graph or invert the graph, would that be a function as well? And so same thing applies. If we draw vertical line, horizontal lines in this case, and here what we see is that this horizontal line is intersecting the function at two different places. So therefore, if we were to flip or invert this graph, the resulting graph that we would have would not be a function. Okay, so cosine of x with its natural domain from being from negative infinity to positive infinity, or all real numbers, is not what we call a one-to-one function. So in this case, what we have to do is restrict the domain. And so it turns out that if we restricted our domain from when x is equal to 0 to when x is equal to pi, that this range of values in between here and here would actually give us a one-to-one function. So we could produce a one-to-one function for cosine. We would just have to limit the domain. Okay, and so everywhere from, let's say, this point here going down like this, stopping here at this point, would give us a one-to-one function. And so now that we have that, you see that we have some of those key points within that particular interval of x values listed here to our right. And so we wanted to come up with the inverse cosine points for that particular function. Then all that we need to do here is just interchange the x and y values. So instead of having 0, 1, we have 1, 0. Instead of having pi over 4, 1 over square root of 2, we have 1 over square root of 2 pi over 4. And then similarly with all the other points, I'll just go ahead and write them out. And our last one here, negative 1 pi. So now we see the cosine function with a restricted domain can actually help us to come up with points for the inverse cosine function. So what we're going to do next is now place an inverted xy axis where what is the y-axis now will now be the x-axis and vice versa, so that we can actually plot points and draw the inverse cosine function. All right, so now that we have our inverted axes, our x-axis now looks like the y-axis in the previous graph of cosine x, and now our y-axis now looks like the x-axis in the previous graph. So all we're going to do is plot these points. So we start off with 1, 0 here. So let's go ahead and plot this now. So we have 1, 0. Now we have 1 over square root of 2 pi over 4, and 1 divided by square root of 2 is approximately equal to 0.0701. So if this is the halfway point, that would be about here. And so pi over 4 would be about there. So we'll plot that. Then we have 0 pi over 2. And then we have negative 1 over square root 2, so negative 0.7, so that's about right here. And that would be 3 pi over 4, which would be halfway in between here. And then our last point would be negative 1 pi. And so now, you see if we just follow the profile, the graph looks something like this.